How you doing? Okay, this video is going to be about the distance to the horizon, right? This is something that needs to be addressed. In my last video, I'll link it, the one I did prior to this, I'll link it in the description. I was pointing out an anomaly, what I thought was possibly an anomaly between a horizon dip on a globe, specifically their 7 over 6 hour dip, which is nonsense because there is no 7 over 6 hour horizon because there's no globe horizon, right? But I was pointing out an anomaly with that, between that and angular size, right, at a distance. Now, it turns out, actually, when I was looking at it originally, I thought, is this just something that's within the geometry itself? And I just went with the video. I said, I'm going to go, sometimes you just go with your gut. I went with the video anyway. Something told me just go with the video anyway. Instead of investigating it too much, just run with it. And I ran with the video, and Prototad, who is a acclaimed professional sailor, and he claims to be a teacher of celestial navigation, he said to me that it was just a coincidence or an aspect of geometry. And at first I didn't go along with him straight away because he said something within the comment that annoyed me, right? Now, if he hadn't said this thing, I would have paid more of attention. I would have been more open to what he was saying concerning concerning the what I was pointing out. But what he mentioned was the distance to the horizon, right? So I'm just going to read his comment, right? Him pointing out what's going on here, right? So from Prototad, 21 hours away from here. It is neither a coincidence nor a nefarious glowy trick that the dip angle matches the perspective angle for double the height. It is just a natural consequence of the geometry. If you diagram it out, drawing a horizontal tangent right at the Earth's surface, and an observer above that tangent point with a downward sloping line of sight to another tangent point, touching a distant spot on the curving surface, you will discover that the horizontal tangent intersects the sloping line exactly halfway between the observer's eye and where it touches the surface. Or said another way, the full distance to the horizon is double the distance to that intersection point, and with perspective calculations, if you double both the distance and the height, yes, and the height, in all caps, you get the same answer, right? So what he was pointing out there was that I was pointing out that double the observer height using the claimed distance to the horizon that was coming from a 7 over 6 hour effective sphere, that you would get using that distance, that double the observer height gives you the exact same angle or size as the dip angle. So the angle is the same, right? So he was just actually pointing out that no, that what I initially thought myself or looked at myself when it occurred to me that it could just be a consequence of geometry. He was just pointing out that that was correct. So he was saying, no, there's nothing going on here. It's just a consequence of geometry. But he annoyed me. So my attention went away from this portion and went to this. He says, the important thing to remember in all this is that Brian, so it became him pointing at me, used the globe-based formula to calculate the distance to the horizon before he ever plugged it into the perspective formula. So the globe was already baked into his answer. The distance to the horizon formula is using the same underlying globe geometry as the dip formula. It is, and he has it in parentheses here, it is why they look so similar, both just taking the square root of the eye height and multiplying by a constant. So really, all he did was invoke the globe-based dip correction formula in a roundabout way. And he says he's going to make a video, I don't know if he did, make a video on it to show it or whatever, right? What's interesting is he says in parentheses here, it is why they look so similar, both just taking the square root of the eye and multiplying by a constant. Basically what he's saying is that the globe dip geometrically is basically you're using pretty much very similar or the same mathematics as angular size, right? Now we know that the globe is just a hijacking of perspective, because when things are claimed to go over the curve of a globe Earth, they are holding the exact same size for the observer because it's all orthographic. There is no angular size change within that paradigm. In their maths, there is no angular size change to the object. It's just how much of it is blocked or not blocked by the horizon, right? So, but this is the problem. I was actually pointing out in the last video, pointing out something, an anomaly, what seemed to be an anomaly to me, about their 7/6 or effective radius. But it works the same with their own normal radius because it's just a consequence of geometry, right? So I agree with him. At first I went against him on that, but I commented today and I agreed, yeah, he was correct, because I checked it last night afterwards. But what annoyed me was he brought up this distance to the horizon. It's like, this man is a professional sailor and he also teaches celestial navigation. So, right, now he's also a glober, right? Now, this is, I'm not going to go into whether I fully believe he's this, that, or the other thing. I don't care, right? Because it's after happening many times where people on our opposing side have claimed to be things and they've turned out they weren't, right? But I'll just take it as read that Protothad is what he says he is, right? I haven't checked him out, but he seems to know what he's talking about, basically, right? Now, he's still a glober. When I say he knows what he's talking about, that's kind of pushing it, because he's done some stuff that nobody who is a navigator would do. But it doesn't matter. I'm just going to go along with him claiming to be a navigator. I don't care, right? Because he's the poster boy or poster child of the globers as a navigator. So rather than argue, it's like arguing whether Wolfie years ago was actually a pilot and all this kind of stuff. I don't care. If someone's claiming to be that, I'll go along with it just to go through the argument, right? So the problem is this, right? This point here, right, in the X marking the spot, that is the horizon, right, on a globe Earth. So based off of viewer height, that tells you where the horizon is, right? But this is based off of a radius, right? Now, if you use a 7/6 OR globe, now remember, the reason that they claim a 7/6 OR effective radius, right, is because that's what they call standard refraction. Is because standard is part of terrestrial refraction. Now, none of them are refraction. That was my point as well in my last video, right? This is all mathematical. What they're actually doing, because what it means is that you are claimed to experience a sphere that is never smaller than a radius of 4618.83 statute miles. You never experience, it's claimed, a globe of radius 3959 miles because the geometric horizon of a globe, it's not a horizon, let's say the geometric point of tangency, which is this point here, right? That this point here, that I'll move around, that this is purely in the maths. And it can't be seen or observed or used as a point of tangency, which is the main point, because of a constant 7/, and greater than 7/6 R. Now, they say, when they say that you experience a globe of radius, that your experience is living on a globe of radius 4618, an effective sphere of 4618.83 statute miles radius. That's not correct, because the horizon, right, this is based off of the distance to the horizon, and the horizon is constantly changing its position. You can stand there and watch it from the same position, spend an hour or two, and you from the same observer position, same observer height, looking out to the ocean, and if the weather is changing, you will notice that that horizon will change its position. Right, this happens. I've literally witnessed it. We've all witnessed it, because the horizon is not a geometric point of tangency, which is what they need it to be. So what did they do? Because they didn't have their point of tangency for a 3959 globe, they started adding in these the effective 7/6, which is the least amount of, what they say is the least amount of terrestrial refraction that there can be, which means there can never be less than 7/6. And the most amount is infinite. That means it doesn't matter how far away the horizon is, because once you can make up a distance to it, you can then, right, or if you have a demarcation point, you can then take the observer height, and I've shown this in videos in the past, the observer height. Adam Meakin gave me, we all know who Adam is. He worked out a formula for using the claimed distance to the horizon and the observer height to determine what size of effective globe you're standing on that day, right? Basically what it means is that they have a never-ending calculation that they can come up with at any point that makes their sphere any size. Like one of them I worked out for BLM-SB 69, seeing an island an horizon at an island 31 miles away. It worked out at 3,500/6 hour, not 7/6, 3,500 or something over 6 hour, 3,800 over 6 hour. It was a crazy amount, and it created an effective sphere of a monstrous size. Do you know what I mean? So this is what they have to do. But the problem is, this is all based off of, they base everything off of an actual size, right? It always starts with a 3959 actual size, and everything works from there. So this point of tangency here, right, that you can't see, right, you can't experience, and you can't measure to, that's the very point of tangency that they're basing everything else off of. But if that is only in the maths, and it can't be seen, can't be experienced, it can't be measured to, then all of their geometry disappears, which it does, right? But yet, we have people like Proto, who's a professional sailor, supposedly, right, saying, I had to use a globe's horizon distance. Now, he's out at sea. Now, what Proto may not know about me is that I have, on both sides of my family, through history, right up to today, have worked at sea. Even my own family name is based around part of what we were known for in history was boat building. I spent time at sea as a child. Now I wasn't sailing the earth or merchant seaman, but I was out to sea fishing, right? Where I was away from land, where I couldn't see land, and it didn't matter even if there was land in one direction, the opposite way from land was always just the visible sea horizon. Now, I can guarantee you there is no way to know how far away that is for definite, because the problem is it's an optical location, and an optical location doesn't have a point of geometric tangency, right? You can do a calculation, but you can't do a calculation for the distance to the horizon and pre-assume a globe. You can't do that, which is what they're doing, and they're doing it with years. And ever since, where has it gone to? Ever since the Black Swan came out in January 1st, 2020. Now, I was attacking them on the horizon for years beforehand, but Quantum Eraser, right, took the Black Swan from BLM-SB 69, and he made a Modus Tollens argument out of it. Ever since this came out, right, all claims of the horizon being a geometric globe edge disappeared. For 5 years before that, the horizon was a geometric globe edge. Straight after January 2020, January 1st, 2020, it was no longer a geometric edge. Now it was a constantly refracted position, because that's what it always was in the maths. And certain people knew that. People like Mick West, he knew it was a constant. He knew that within those maths, the claimed globe's geometric edge didn't exist. Only within the maths, it didn't. The horizon we see was not claimed to be it. The horizon we see is claimed to be a consistently refracted position. But that claimed refraction is based off of a geometric globe of 3959 miles. And to base it off of that, you would have to be able to experience this green, right, and move it around, point of tangency. So this horizon point of tangency for a globe of 3959 miles, you would need to be able to experience that to make that measurement. Now, if the horizon is constantly moving around and it's never holds any constant position in relation to the eye height, right? So no matter what your eye height is, the horizon can change in its apparent distance to you. That means that there will be no way to ever know, even if there would be no way to ever know if you even had an actual geometric edge, because you wouldn't be able to know whether it was there or not. So what they did is their maths is all back engineered from flat Earth elevation angles to Polaris. I've shown this in the past. That's where the radius comes from. So they're taking a calculation that's a back engineering of flat plane measurements, and they're then pre-assuming based off of this calculation the distance to your horizon. But then because the horizon is not a constant adhering to your eye height, they're then adding mathematical refraction, right, to change that position based off your eye height, right? And your eye height can stay equal while this point moves about. Because, and how they do that is they just increase this purple line, they increase the sphere. Technically, you're always living on an arc length, according to them. You're never living on an actual sphere. You're always living on some form of a refracted arc length, right? This is how ridiculous it is. But how can you base a distance to the horizon, right? How can you base that and using any kind of over 6R calculation that's based off of a 3959 calculation if you don't have any original measurements outside of flat plane measurements? You can't. So when people like Proto, right, try to underneath the table add in a distance to the horizon, which they do try to do. Now, what people don't realize is in celestial navigation, the distance to the horizon has no bearing whatsoever. There's no bearing in celestial navigation. Most of our opposing side don't realize that dip correction is just based off your height of eye. It is not about the distance to the horizon. Now, they do try to add in a mathematical distance sometimes, but it has no bearing on it. You're just correcting for your height of eye, right? And if you look at the calculations, they do not match a globe, and they don't even match 7/6R, right? They don't match those, right? They match a horizontal plane. That's what they match. Now, they've even tried to mess with that, and that's future stuff coming up. They've even tried to mess with that, which they have. But the point being is that within celestial navigation, something that Proto does, there is no distance to the horizon that matters. You're not dealing with that. You're using the horizon, but you're not using it as a distance marker, right? It's right, not for your height of eye. So my challenge is this to Proto, because he's a acclaimed professional sailor and a teacher of celestial navigation, and he's claiming a distance to the horizon. Then how do you get a distance to the horizon if you don't use your globe? Because your globe is only pre-assumed calculation. There's no measurements for it. There's no measurement of a globe. This is the whole point. This was the whole point of the Black Swan. It took away the geometry. You don't have any geometry. So you can't do any geometry, right, on the surface of Earth without treating it as a flat plane to have any, to get any, anything that would be considered valid. You can't treat it as a globe and get any kind of valid geometry. You can't. So my challenge to Proto is, and all the rest of the board side, is that for the past 4 years you've claimed to know the distance to the horizon. You're basically begging the question, adding it in underneath the table, while not claiming that the horizon is a geometric edge of a globe. So how are you getting this distance without, right? My challenge is this: get the distance without pre-assuming your globe. Because you can't pre-assume the globe because it's not geometric. You don't have any geometry. So how do you know the distance to the horizon if you don't have any geometry? Without pre-assuming a globe, how do you get the distance to the horizon? Right? How do you get it? Let's just look here. How far away is the horizon? Moment of science. I'm just going to read this part, right? Flat Earth, right? Think about it. The Earth seems flat from our viewpoint. And if you were in a desert or out at sea, you get a sense that the Earth extends indefinitely in every direction. This isn't correct though. The planet is round. So there's the adding in of a planet, right? Of a particular radius. So at some point the ground must drop away. When it drops below your angle of vision, this is just so what they're basically saying is, if the horizon is below your eye line, then you're on a globe. That's what they're saying. It's like, no, if you were above a horizontal plane, then your eye line is only making a parallel with the horizontal plane, because the horizontal plane is below you. But that doesn't mean that we're suddenly on a globe. This is the pre-assumption, right? And if it finishes out, you can't see it anymore, and that's what we call the horizon. So they're invoking a globe's geometric edge, trying to claim this is the globe's geometric edge, right? Second one, next slide. Sorry. Right, how far away is the horizon? Math space, right? Here you have, look, if you kept going, that's a drone that keeps going forward, you'll never make it to the horizon, right? Because it's just an optical phenomenon. It's an optical location. It's not a geometric point of tangency. It's not a geometric location, right? And here, what do? They work it out, and what do you know? They pre-assume a globe. That's what they're doing, right? I don't know how they have a 90 here, but they do. They're pre-assuming a globe, right? And they give you all the nonsense, and there's your height, there's the radius. Look, the radius of the Earth, right? And they give it here in kilometers. So it's a big pre-assumption. They go through all the calculation here to work out how far away the horizon is. And for a 1.5 meter eye height, the horizon is 4 kilometers, 371 meters, blah blah blah, right? It's a joke, right? But this is what they do because they pre-assume that they're on the globe. So, right, but you can't do that because the geometry is broken. It never existed. That's what we found out. The geometry the maths exist, but the actual real world geometry never existed. The only real world geometry is flat plane geometry. Treating the Earth as a flat plane, that's the only real world geometry. So how do you know, right? Here's that picture from that one of the websites. If you didn't know your distance to that boat, right, you can't even make some kind of an ad hoc calculation to how far away the horizon is, right? Just off of just basic standing there, you can't know, right? So if you take that boat away, you just have this place out there, this optical position out there that you don't know anything about. Here, how do you work it out with this one, right? How do you work out how far away you are from that, right? You can pre-assume you're on a globe, right? And then add 7 over 6r, right? So you do your maths for the 3959, then you do your maths for the effective 4618, and you give yourself a mathematical distance, but that doesn't give you an actual distance. That's you pre-assuming that it's a distance. So people like Proto is trying to, like, he was pointing the finger at me for using globe distances. It's like, I'm not saying those distances are real, Proto. Do you know what I mean? You're pre-assuming these distances, right? So if I pre-assume a sphere, I come up with a calculation, but that calculation has no bearing whatsoever on how far away that horizon is from me. Considering that an horizon from 1 foot observation height can be, like, this one here is at least 10 miles, but you don't know how far away it is. And in BLMSB's, one of his other videos, he has several other videos where he's showing horizons at mad distances, at great distances, and one of them has an horizon at 31 miles away or something like that, 28 or 31 or something. So from a 1 foot observation height, and you can see it happening in real time. So it's like, how do you know how far away the horizon is? You don't, Right? You can't tell how far away this horizon is. Even if you knew the point directly below that airplane, if you knew where the airplane was at that time and its coordinates and its point directly below, that still won't tell you how far away that horizon is. It'll only tell you how far away you are from that point, right? And that's it. And that will be a straight line distance. So I'm just going to show something here, right? This is you looking out over the horizon. How far away is it? You can't know, right? There's only one way you can somewhat know how far away the horizon is. And unfortunately, it's not the globe. You can't use the globe for that because that's just a calculation. I'm just going to show something here, right? One more, right? Here you are on a boat. I've seen this many, many times. Been on a boat looking out. That's exactly what I saw. So many times on boats looking out. That's what you see. And depending on the weather, the horizon will appear closer or further. But because you're on a boat, you can't even tell unless there's a massive change. You can't even tell if it started appearing to be anything because you're looking out at the same line, the same horizontal line in the distance as a constant. You just can't tell how far away that is for definite. You just don't know. So my challenge to the ballers is this: is how do you work out the distance to the horizon in reality? You can't use your globe because this is for Proto, right? I want this directed to Proto, and I would like if the people watching this video directed it to the ballers constantly, all day, every day. Where are you getting your horizon distances from when you don't have any geometry to support them? The only geometry you have is flat plane geometry. You can't use a globe. So without pre-assuming your globe, how are you getting a distance to the horizon? Right? This is for Proto and Charles Glober Math and all of them, right? Every one of them. Please hound them with this. Because ever since January 1st, 2020, they've tried to add in a distance to the horizon based off of their globe, right? Starting with their 3959 geometry and then adding in over 6 hours, some form of over 6 hours they need to give themselves a distance to the horizon. That's purely a calculation based off of geometry, a completely unmeasured, basically real-world geometry. It's a calculated geometry based off of hijacking of flat plane measurements. They don't have any globe geometry. So for them to add in a distance to the horizon at any point is completely criminal. You have no business adding that in. You can't use it. From here on in, do not let them use it because that's them begging the question of the horizon being somehow connected to a globe when it's not. It has nothing to do with a globe. It has no connection to globe geometry, right? Because globe geometry is purely calculation. It is not measurement. So how do you find the distance to the horizon? In reality, right? For Proto, for Charles Glober Math, for all of them, right? Right? I'm just throwing out those two names, right? Because they're known for maths. All of them. I want to know, how do you calculate the distance to the horizon without pre-assuming a globe? Because a globe is just your belief. It has no connection to reality. It's just your belief. That's all it is. So if I had to calculate a distance to the horizon, right, let's just say I'm 60 foot here. Let's just point C is 60 foot, right, above the water here. Let's say that's the water in blue, and the green is eye line, right? The red line here, I'll just make it serrated. That is my angle to what my perceived horizon. That's the best I'll do. So that's my dip angle to my perceived horizon. Now, the point of this is I don't actually know if that's not actually this here. That's not actually the horizon, as in that's not an actual geometric point that's going to be constant. For that very moment, it appears that is where my horizon is. But while within half an hour, my horizon could be here. I could have a dip of that to the horizon, or out here, a completely different dip angle to the horizon, because the horizon is constantly moving. right? So there, right? So how do you know the distance, the actual real world distance to the horizon? You certainly can't pre-assume a globe and think you're going to get it. The only way, the best you'll do is what I'm going to do here. This is the best you're going to do to get a distance, an actual real world distance to the horizon. And the problem is this is going to be momentary, because this distance that I'll calculate now, right, which will be the calculation of this green line, the length of this green line, that distance will only be at that moment. As I said, half an hour later, that could be my presumed or my apparent distance, or this could be, you just don't know where the horizon is going to be. So even this is not correct, but it's at least somewhat correct, somewhat based in reality. I'm not pre-assuming a distance based off of the pre-assumption of living on a sphere that has no measured geometry. I'm not doing that. So if I take this angle here of 12.0947, right, and I take a height of 60 feet, right, and I use a triangle calculator, right, so 60 feet, that's A, and this angle of A here is 12.0947, and I calculate it, right. So I need to know what B is. So B is 280, right, 0.000136. Now, obviously, the horizon is going to be more than 280 feet away from you, but you get the idea, right? Because I'm not going to have, from a 60-foot observer, I'm not going to have a dip of 12 degrees, right? But there's no point in me trying to show what it probably would be in reality here, because the scale would be too massive. So the only way for me to even attempt to get any actual distance to that point, which is just an optical point, right? The only way for me to even get any ad hoc distance that matches in any way reality is to use an eye line that's parallel with surface level. So eye level parallel with surface level. That's the only way, because I can't do this here that I just did and have sea level be a curve, because that won't be a distance to the horizon, because I must use parallel, right, verticals. So I can't calculate my eye line as being 280 in length and this be a curved line. Because let's just say I calculated that as 15 miles, 25 miles, let's say, my eye, right? This here is, if that is curved, is going to be more than this. So the curved line between these 2 points, between point A and point B, is going to be greater in length than between the point C and point D. So the only way I can do it is pre-assume a flat Earth. That's the only way I can do it. And at that, it's an ad hoc bit of trigonometry. That's all it is. But at least it's somewhat based in reality. I'm not pre-assuming a globe, and then based off my eye height, I'm pre-assuming where my horizon will be because of my eye height. I'm not doing that. I'm using my eye height and the dip, my apparent dip to this apparent position, to get an ad hoc straight line distance where my eye line and where eye level and sea level are parallel horizontals. That's the only way that you can do it. Now, this is to finish the video. My challenge is there. Please, flat earthers, please continually challenge our opposition on this. I want this to go to Proto and Charles Gilbert Math, Ruhif, Blue Marble Science, Bold the Science Guy, Fight the Flat Earth, all of them, right? I want them to show how they gain a distance to the horizon without pre-assuming that they're on a globe to begin with. And I guarantee you, the best they'll come up with is exactly what I've just done here. And even that is only ad hoc. But I've had enough of them claiming a distance to the horizon. I've had enough of that. Prototad is out to sea, claimed to be, all the time, or was, right? So he should know that there is no distance to the horizon. You cannot actually gain a correct distance to the horizon. It can't be, because the horizon is not a geometric point of tangency, right? the point here that I'm getting is just a point on the water, right? But the problem is that if they can come back with anything, they have to then pre-assume that the water is horizontal, and that the point that you see at the horizon is still water, meaning that it's not some dodgy mathematical refraction that's not refraction, that's made up to explain why your globe doesn't work, your globe that has no measured geometry. It's not any of that. It's actually water at sea level, a horizontal. So I want, please, I want you to task them with this, hound them with this, because this is the final nail in the coffin. This is it. If they can't come up with a distance to the horizon without pre-assuming a globe or sphere of a particular size, then they don't have an argument. Not that they have one anyway, but they've kept themselves in the argument by slipping in a distance to the horizon underneath the table in different ways. So don't allow them to do it. Don't allow them to do it. Make them come up with a formula or way of finding the distance to the horizon without pre-assuming a globe or sphere of any particular size, or any earth of any particular aspect or shape. How did they do it? Because they can't use the formula they're using. No more of that. No more of that nonsense of, oh, well, the horizon is, when we add in terrestrial refraction, the horizon is this far away. It's like, no, you can't determine the distance to the horizon just off of your eye height alone. That's begging the question. It's pre-assuming your outcome. It's fraudulent. No more. It's over. I'm done with it. And the more that flat earthers realise that is the end of their paradigm. Don't allow them to insert their globe. Don't allow them to have a distance to the horizon based off of a pre-assumption of a globe and using the right height. Don't allow them that. Right? So I want this challenge to go out to all of them. Show me how you get a distance to the horizon without pre-assuming your globe. Because your globe died, right, when you admitted you didn't have any real-world measured geometry. When it became obvious that there was no real-world measured geometry, that ended your globe. So you cannot, Proto, any of them, right, Charles Globe, Math, any of them, you cannot pre-assume your globe and pre-assume a distance to the horizon. You can't do that anymore. It's over with that stuff. Thanks for watching.